Hello, this is Herb Shapiro of the Dr. Vax channel, and I'm a very lucky guy. I've recently had the opportunity to review a number of 3D printers, and we have another new one here today. This is the ANET ET4. This was sent to me by ANET for the review, but it came to me in an interesting way. They sent me two printers that had been returned to Amazon. And the reason they sent me two is they weren't sure what was wrong with them, why they'd been returned, so they wanted to make sure I had the parts to assemble a single 3D printer. So stay tuned, I'll tell you the full story, and we'll learn something together. So it ends up I only needed to use one of the 3D printers they sent me. I opened it up. I found that the fuse, it wouldn't turn on. The fuse was blown. Now, fortunately, on the ANET printers, I'll show you a picture of this on the screen. Right next to the power on-off switch is a place to replace the fuse. So you can replace the fuse on this printer without opening up the base at all. That's really quite nice. In fact, the overall fit and finish of this printer is really quite good. I like how it sits on a very solid base. The power supply is fully enclosed. This would be a very safe printer to have around children. And it looks nice. I think the red and black look quite nice. So now let's go through the rest of the overall features, because one of the things I want to do for you today is help you compare this printer to other printers of this class. This printer is available today from the ANET website for $209. It's available on sites like Amazon for about $230 to $250 depending on the seller. So they're readily available. The printer is a 200 by 200 square base with a 250 millimeter height. So basically, it's an Ender 3. It comes with a glass build plate. Now this build plate clips on with these little clips, and I'm pretty sure I'll lose these at some point. So probably something I want to get more of. I don't know if this is just plain window glass or this is special glass. It works great. It does a really, really good job of absorbing the heat from this heat bed. These clips are quite easy to use, and I've had no print failures. Now, I do cheat a little bit. I put a little bit of magic goo on the plate before every 4 or 5 prints. And the combination of magic goo, and if I'm printing a complex object that does not have a solid base, I'll use a raft. I've had no print failures because things have come loose from this print bed. You level the print bed one of two ways, theoretically. First, there is assisted bed leveling built into the firmware. That works really well. You select bed leveling from the menu, and then there are buttons for corner 1, 2, 3, 4. You press a button, it moves the print head to the appropriate corner. And then there are nice sized knobs underneath. You use the knobs to adjust the height. I use a post-it note between the nozzle and the print bed, and I go around a couple times. But the assisted bed leveling works great. There is also automatic bed leveling. Now, the automatic bed leveling works by plugging the sensor in here on the top and then putting this contraption on the nozzle. It doesn't work. There's a bug in the firmware. And when you go to use it, the Z-axis goes all the way up to the top and continues to turn the stepper motor. I verified with ANET that it's a known bug. So as far as this review is concerned, there is only assisted manual bed leveling. Now, even when this works, it's not quite as useful as a dedicated sensor. And the reason is you can't run a bed mesh check to determine the heights of the bed right before a print, unless you do it manually. So I'm not a big fan of this approach. It didn't matter. This is a glass print surface, so it is perfectly flat. So if you get the four corners correct, your bed's going to be great. And I produced really nice prints on this. And one of the nicest things about using a glass print surface is the bottom of the prints are really beautiful. They're shiny and nice. So print bed is glass. We've given you the dimensions. What are the other key features of this printer? This is using a proprietary 32-bit processor board. ANET in the past had a bad reputation for shipping printers that did not have thermal runaway protection. What that meant was if the electronics was heating up the nozzle and the thermistor wasn't working, the thermometer in essence, the detection of the temperature wasn't working, potentially it could start on fire. They've made a big deal in all their promotional literature and their literature with the printer that this is a whole new control board. It has thermal runaway protection. It has a filament out sensor. I'll show you a better picture of this on the screen, and it works great. It has pause and resume, and it has power fail recovery. And I've tried power fail recovery. That works great also. So because it's a 32-bit board, there's more memory space for features. And those features have been included. We'll see when we look at the pros and cons, though. Today, they have not made their firmware open source. So I'm not even sure it's Marlin-based versus completely proprietary. But I'll show you that in the pros and cons, that it doesn't support all of the traditional Marlin G codes. What does that mean? It means that if you're using an aftermarket product like Octoprint, Octoprint is a way to control printers from a Raspberry Pi. That works, but some of the plugins don't work because it doesn't support all of the features. If you're directly connecting the printer over the USB port, and there is a USB port here, and you're sending commands manually, some of the commands like an M503 do not work. M503 is a command to say, tell me about your firmware and what all your default settings are. So the firmware, and they've already released multiple versions, still needs a bit of work. The construction of the rails is very, very good. But there is one feature that is very different between this and most of the other Ender-style printers I've seen. And that is that the sensor to determine the Z-axis height is here. And it's triggered when this hits the top. So when you tell the printer to home, let's actually show you that, because it's better to see it. So we're going to turn this on. It has a full color display. The display is not standard, meaning it doesn't, if you attempt to send information to the display, that's an M117 G-code command, that won't work. There's no place for that information. It is a touch screen. The touch screen works very, very well. So let me go ahead and home the printer. I'm going to turn this just a bit. Okay, I've turned the printer so that we can see it better. Now let me turn it on. And you'll hear that it's really quite quiet. The fans on this printer are quite quiet. I'm going to go to the front panel and click on Settings. And then I'm going to click on Home so you can see how the behavior of this printer is not traditional Ender-style behavior. It's going to go to the top, trigger this Z-axis sensor, so it will know where the top of the scaffold is, the top of the frame. And then it knows the measurement down to the bed, which is a different way to do it. So let's hit home. Now, it does tend to be very, very reliable. I think one of the reasons it's reliable is the combination of the cabling and the mechanics are very clean. On this printer, there is a single large cable that comes from the base to a distribution panel, and I'll show you a picture of that now, to a distribution panel on the top. And then to assemble this printer, you just plug in all your cables to that distribution panel. Overall assembly is very easy. You screw this top mechanism into the base, you slide the print head over the X-axis, and you attach the belt. Then, because the cabling is so clean and everything is clearly marked, you attach all the cables. We're now ready to print. Now, what were the results of the prints? Well, the first print I did was a print off of the SD card. The majority of the prints on the SD cards are cookie cutters. I think those are terrible sample prints. Other printers have cute little animals. This actually came from the Monoprice Cadet. That's actually a beautiful print. That printer is excellent quality. This cookie cutter was fair. Now, I did test pause resume using this cookie cutter, and one thing I can tell you is that if you pause for a long time, the nozzle is going to cool down a little bit. And your print is actually going to cool down a little bit. In particular, if you've had a power fail outage, everything's going to cool down. When it goes to resume, you may be able to see a visible line at the layer it resumes because the adhesion is not quite as good. So I probably wouldn't even bother with the prints off the SD card. Instead, I started printing my own prints. So let's look at some of these prints. Well, I printed a whole bunch of these calibration cats. I'll show you a close-up of one of these. These are excellent because you can take a micrometer or a caliper and you can measure the dimensions of the cat. And this printer did a really nice job, but not perfect. Why not perfect? Well, initially I used the profile that was available for Cura on the ANET website. I don't think that profile is very good. So what I did instead, and I recommend you do this, I went into Cura and I created a new printer based on the Ender 3 profile. Now I'm running Cura 4.5. Any of the 4.x versions of the Ender 3 profiles are really quite good. So I started with that profile and then I fine-tuned it. I had to adjust retraction a bit as an example. And I'll share that profile on Google Drive in the comments below this video. So you'll see I have a whole bunch of these calibration cats here because I can't remember what I change when I'm tuning a profile. So I just print them with a raft and I write it on the bottom. Okay. Now after printing that, I went ahead and I printed a simple stringing test. This came out perfect. Then I went and I printed the Kickstarter calibration test. And here on the very top, I did get a lot of stringing. So I did some more tuning on the profile. I was able to get it to be better. And here's some more examples that I printed on this printer, but not perfect. In reality, the very top of these towers are not a realistic test. This stringing test is a better test. Why? There's enough volume. There's enough, these are large enough, these posts, that when the printer goes to print the post, it can deposit filament that's the volume of the size of the nozzle. So if you're trying to print something that's less than 0.4 millimeters, and the very tops of these towers are less than 0.4 millimeters, it's really hard for the printer to control that. In particular, a printer that uses a Bowden tube, and this is a Bowden tube style printer, finds that difficult. Now, is it possible to do better? Yes, it is. So this tower was actually printed on my Prusa i3 MK3. There's still a bit of stringing, but it's a bit more precise. And in fact, the very best calibration tower I've ever printed is from the Monoprice Ultimate 2, but both the Prusa and the Monoprice are significantly more expensive. This is a $550 printer. This is a $750 kit or a $1,000 printer, and they're both direct extruders. Controlling the flow rate of very small items with a Bowden tube where there's slop in the tube is more difficult. Do I think I could do perhaps a bit better on this? Perhaps I could by replacing this tube with Capricorn tube. But this was printed on my Ender 5. Now my Ender 5 has a all-metal micro Swiss hot end, which tends to string more. But this is about the same, maybe slightly better. So after printing this, and then these versions, which are just the top half, I just sliced off the bottom and only printed the top. I said, you know, maybe to get a full feel for this printer, I should print some more typical things. So the next thing I did is printed a train car for my grandson. It's a beautiful print. It's really a first-rate print. Then I printed a butterfly. But I had been doing some experiments before, so this butterfly, which came out perfect, is very interesting. I stopped it before the end. Why? I realized I was printing this in vase mode. So this was printed with absolutely no fill, and it still works really well. Then I printed a large vase. This vase is gorgeous. As nice as any vase I've printed on any Creality Ender style printer. In fact, I think this is as nice as vases I've printed on much more expensive printers. I did one more complex print and this lattice cube, and other than just a little bit of stringing, this came out remarkable. So overall, I'm really impressed with this printer. But now, to get a full picture, let's compare it component by component to an Ender 3 Pro. Today they sell for about the same amount of money. Depending on what's on sale, one will be a little less expensive than the other. And I'll put this up on the screen for you so you can see these comparisons. Well, first off, this is a 32-bit control board. So there's the potential for significantly more upgrades to the firmware. That said, one of the things I like to test is the compatibility of the firmware with third-party components, specifically Octoprint. They both work. The Ender 3 Pro and this both printer, the ANET ET4, both work with Octoprint. However, because of the proprietary firmware in here, which doesn't support all of the G codes, some plugins will not work. All the standard plugins pretty much work on the Ender line. The Ender 3 Pro claims a Meanwell power supply. Now, Creality has a mixed history with power supplies. I have an Ender 5, which has a Meanwell power supply. Later Ender 5s did not. It had a generic power supply. This has a generic power supply. Both printers have PowerFill Resume, thermal runaway protection, and this printer does have, and let me turn this for you so you can see it. You see right here, this printer does have filament runout protection. So if the filament breaks or you run out of filament, when it gets past this sensor, the printer will stop. And it will stop before the print runs out of filament. You'll then need to unload the current filament that's left, and there will be some left in here so you can get to it, and then resume the print. Nice feature to have. And that's standard on this printer. In terms of assembly, this is a little easier to put together than the Ender, and the reason for that is this wiring harness on the back. The single cable that goes to here, everything is really well labeled. And in fact, the power cable to the base is just done real well. So the overall construction, in particular when it comes to cabling, is better on this printer. It is fully enclosed. I think that's an advantage. Touchscreen versus the Ender screen. Pluses and minuses. The touchscreen works great. I had no problems with it. It's appropriately sensitive, it's full color, but it's proprietary. So my Octoprint plugins that display things on the screen don't display them on this printer. On an Ender they do. On the other hand, the Ender display is fine, it's monochrome, but the knob on all the Ender printers, I've had multiple Ender printers. I have Ender printers at each of my grandchildren's homes, and I have an Ender 5 here. The knobs tend to fail at 6 months to a year. The replacement knobs which include the control underneath that you order, or at least that I've gotten, tend to be not perfect. There'll be dead spots. So this color display is really nice, but it's proprietary. So that's a trade-off, not a plus or a minus. G-code support is better on the Ender than on this machine. That can be fixed with a firmware upgrade. And overall print quality is almost identical. So, do I recommend this printer? Yeah, I like this printer. I really like the printer. Would I recommend this over the Ender 3 Pro? I think that's a personal choice because they're very close, but they're different. There is one wild card. There's a version of this printer that's supposed to have the enhanced stepper motor drivers. It's only $15 more. It used to be listed on the ANET website. It's no longer there. It's probably back-ordered already. But if you can get the version that's $15 more with the enhanced stepper drivers that do micro-stepping and will make the printer absolutely quiet, this is a better printer. But you can order an enhanced control board for your Ender 3 Pro for $35 from Creality. Now you have to install the control board yourself. A little bit tricky, not terrible. It is plug and play. You just plug it in and you're ready to go. So which do I recommend? Once again, personal preference, and they're very close. They're both really outstanding, excellent printers. Folks, thanks for watching. I hope you learned something today. I like this printer. I like the Creality Ender printers. We live in a wonderful time because we have so much choice, and let's continue to print and share beautiful things together, to learn things together. If you like the channel, give me a thumbs up, subscribe, share it with your friends. Have a great day. Thanks for watching.